In this video, we will review all of the different types of transformations. Problem number 1, which of these rules would translate a preimage down 2 units? Well, if we're talking about down, we're talking about the y value, and -2. So, kabam! C. There's your down 2. Okay, problem number 2. This point is rotated around the origin. Its image is this. What type of rotation occurred? So when we're rotating around the origin, if we do 90 degrees clockwise, the rule is xy becomes y negative x. All right? We just had to memorize that. There's no way around it. Just have to memorize that rule. If it's counterclockwise, then your point xy becomes the point negative y comma x. All right? In either case, the coordinates reverse places. All that changes is whether the y value stays the same or if the x value stays the same. So memorize these rules. If there is a 180 degree rotation, then your general point x comma y becomes negative x, negative y. So that's the situation where the only thing that changes is the signs. So the question is, which one of these things happened? So first of all, did the coordinates trade places? I see a 7 and a 12. I see a 12 and a 7. So there's definitely a reversal of the coordinates. So that means it's either A or B right there. So now the question is, which coordinates stay the same? So I see negative 12, okay, the x value, all right, and I see negative 12 right here. Okay, well, I guess when it started off, it was the y value. So this y value came here, but the signs did not change. The x value changes, but the y value stayed the same. All right, so that means it must be A, because that's the one where the y value stays the same. Okay, so the answer is A. All right, looking at number 3. Which of these rules will dilate a figure from the origin by a scale factor of 4? Dilating from the origin is simple because you just multiply the coordinates by 4. So that's definitely going to be B, because you just see that we're taking x and y and we're multiplying by the scale factor. So there's really nothing more to it than that. It has to be B. Okay, problem number 4. This quadrilateral is dilated from the origin to create this. What is the scale factor? Well, all we really have to do is examine one pair of coordinates. Now notice, okay, let's see. Let's take the point P for example. The point P is the point negative 3 comma 3. Okay, and it becomes the point P prime, which is negative 1 comma 1. So notice that the new quadrilateral is smaller. So that tells us that the scale factor is less than 1. All right, so right away we know that is not going to be A or C. In fact, when we're looking at C, we don't think of a scale factor as being negative. So really, as soon as you saw a negative scale factor, hopefully you were like, what? And you cross that out. And really, it can't be D either. Even though there's a decimal in there, 3.3 is bigger than 1. That would cause the shape to be getting bigger. So it really has to be B, okay, just because it's the only one that's, between 0 and 1. It can't be negative. It's the only positive number that's less than 1. But other than that, let's imagine if we wanted to get, for example, from 3 has become 1, well, that would have been 3 times 1/3 would equal 1. Or you could think of it as the only way you're going to get from 3 to 1 is by dividing by 3. And multiplying by 1/3 is the same thing as dividing by 3. So that must be what happened. Alright, so the answer was B. Alright, number 5. Which graph shows an image and pre-image after reflecting across the line y equals x? So first you have to understand that the line y equals x is a diagonal line going up 1 over 1, you know, at like a 45-degree angle. Okay, that's the line y equals x. So we're looking for two images that are reflected over this line. They're mirror images of each other. Both of these are on the same side of the line. So that can't be A. Right? Looking at B, same issue. Okay? Both of these images are on the same side of the line. So they are not mirror images of each other over the line y equals x. Alright, so only C and D even have a chance at being the answer. Alright, once again, drawing this mirror image, drawing the reflection line, y equals x. Now just visually, I can see that C is going to be the answer. Because I can see the way that they are mirror images of each other. So the answer is definitely going to be C. D looks more like some kind of a rotation or something. Now, if you weren't 100% sure, here's what you could do. You could look at the coordinates and think about the rule. When you do a reflection over the line y equals x, the point x comma y should become the point y comma x. Alright, the coordinates just reverse. That's the rule for reflecting across the line y equals x. You should memorize this. So let's look at an example and see what happened. Okay, so for example, let's look at this point right here in the corner. That is the point -2, 5. Okay, so let's see. So we have the point -2, 5. So that should become the point 5, -2. Is that what happens? So let's look at the point 5, -2. Boom. We have a corresponding point. And we could check any of these points and the same thing would happen. Okay. Now, let's check the other graph. I'm going to change colors. Alright, so that was graph C, and everything worked out. But now let's check graph D. Let's check that same point. Okay, we remember the point was -2, 5. Alright, so it should become the point 5, -2, just like we already said. But look, if we go to the point 5, -2, alright, the image of this point should be right here, but there's nothing there. Alright, so this is not following the rule, so that's a way of just proving to yourself that D is not the answer. So the answer is C. Okay, problem number 6. For the translation that's given here, the image of a point is this. What are the coordinates of the pre-image? So remember, in terms of this terminology, the pre-image becomes the image. Okay, the pre-image is like the before picture, and the image is the after picture. And now here they've given us this rule, but this rule represents the pre-image, xy, and how it becomes the image, x minus 5 and y plus 2. So this little formula is a formula for the image. But then look, look what happens. They've given us the image. The image is negative 4 comma 15. This expression is the image. So the image equals negative 4 comma 15. In other words, this point, you know, with the expressions in it, equals this point that we know. So we can break that down further and think to ourselves, okay, x minus 5 equals negative 4. And y plus 2 equals 15. All right? The x-coordinate equals the x-coordinate. But we can solve these for x and y, and that's what the pre-image is. And that's what we're supposed to find. So over here, if I add 5 to both sides, all right, that's going to give me x equals 1. All right, so that means the x-coordinate is 1. If I subtract 2 from both sides, that's going to give me the y value of 13. So that's why the y-coordinate is going to be 13. So the pre-image is 1 comma 13. And if you think about it and you sort of plug it back in, you'll see that it makes sense. All right, we're supposed to be finding the original point. So we are claiming that the original point is 1 comma 13. And this point is supposed to become the image. Now the rule says subtract 5 and then add 2. All right, that's what the rule does. So if we were to subtract 5 and from the x value, and if we were to add 2 to the y value, what would happen? Well, if we subtract 5, won't that give us negative 4? If we add 2, won't that give us 15? So isn't this the pre-image that gives us the image that we are supposed to get? So that's a way of checking your work. All right, a common mistake is just to take the rule and to just apply it to this point. That won't work because this is the image. You can only just apply the rule to the pre-image. Anyway, that's too much time on one problem. Let's move on to number 7. Point A is located at this point. Find the coordinates of the image A prime after the point is reflected across the y-axis. This is the perfect time to use the rule. The rule for reflecting across the y-axis is that xy becomes negative x comma y. In other words, when you reflect across the y-axis, the y value stays the same. The x value changes signs. So that's what we need to do, just apply the rule. So 12 comma 25, the y value should stay the same, so I should still have the 25 happening. The x value changes signs, so I should have negative 12. Whoops. Negative 12. So that's it. I should have negative 12 comma 25. All right, just change the sign of the x value, keep the y value. Don't change the order or anything like that, which is what some of you did. Okay, moving on to number 8. Draw the image of segment DE after it is reflected across the line y equals negative x. Label both endpoints of the image. Okay, so the line y equals negative x is a line that goes downhill from left to right. So you could do this graphically if you wanted to by drawing the line y equals negative x. And then you could just look for the image by counting diagonal squares over this line. So you see the point D right there? D prime should be right here. It's just a point D is a half a square above this line. So if I go, diagonally, so I will find half a square on the other side of the line. That should be my D prime. And then point E is a square and a half away. So if I go, there's my half, here's a square. All right, that should be E prime. Okay, so if you're comfortable with that graphical method, that's probably the quickest way to do it. But there is another way you could have done it. You could have used a rule. Okay, so remember that the rule for reflection over the line y equals negative x is that xy becomes negative y negative x. In other words, we reverse the coordinates and we change both signs. So you could have done that pretty easily. So you could start off by saying what is point D, and that was the point 2 comma negative 1. And then what is the point E, and that is the point, let's see, 2, 4, 5 comma negative 2. All right, so what will they become? So D prime, again, we're going to reverse them and change both signs. So that's going to give me a positive 1 and a negative 2. And then E prime should be a positive 2 and a negative 5. And then we just plot those points. So the point 1 comma negative 2 is right here, just like we thought. And the point 2 comma negative 5 is right here, just like we thought. So you could have plotted the points that way instead of counting diagonally. Either way would have worked. All right, moving on to number 9. Draw the image of JK after a 90 degrees counterclockwise rotation around the origin. Okay, label both endpoints of the image. All right, so again, there are two ways to do this. You can do this graphically, or you can use the rule. If you were going to do it graphically, we're rotating around the origin. So the way you would do it graphically is to draw the path to one of the points. So, okay, the path from the center to J is like this L right here. Okay, or this arrow. I'm doing the arrow method. So if I were to rotate this counterclockwise around the origin, counterclockwise is this way. Here's what that path would look like. Alright, so see this horizontal piece that's length 3? If I rotate that counterclockwise, that's going to end up being straight down. Alright, and then the rest of the arrow would branch off in this direction. Let's see, this is 4. So I'm going to go 1, 2, 3, 4, arrow. Okay, so that's what it would look like if I rotated this arrow, this path, 90 degrees counterclockwise. And the end of this arrow tells me where the point J prime is. Okay, so that's one way to do it, the arrow method, rotate the path. And I could do that again for point K. Alright, for point K is like right 1 and up 3. If I rotate this 90 degrees counterclockwise, it's going to look like this. Up 1, left 3. Okay, so boom. This should be the point K prime. Alright, and then I would just connect these segments, connect these endpoints, and then we're in business. Just going to change the color, bear with me. Alright, so there you go. So that's how you would do it graphically. Alright, the arrow method. Now, as I did on the previous problem, the other way you could do this is by using the rule. If you know that the rule for a 90 degree counterclockwise rotation is this, alright, xy becomes negative y comma x. They're going to reverse places, but the y value will change signs. The x value doesn't. Alright, so if you have that in mind, the original point J is the point -3, 4. And the original point K is the point 1, 3. Alright, if I use the rule, then that should give me J prime. Alright, so I'm going to reverse these and change the sign of the y value. So this will become -4. The -3 is going to stay -3. K prime, okay, the y value of 3 will become -3. The x value is going to stay what it was. So J prime, K prime. So let's check it out. J prime, that's -4 and -3. So if I go to -4, -3, there it is, just like we thought. And K prime is at -3, 1. So if I go left 3 and up 1, oh look, there's K prime just like we thought. So either method will give you the same answer. So take your pick. Okay, now problem number 10. Draw the image of this segment after it is dilated from the origin by a scale factor of 2. Now, really by far, I think the easiest method for this would be to use the rule. If you're going to dilate from the origin, the rule is just so simple that I would find it a bit silly to use the graphical method. I'll show it to you, but come on. So if you're going to dilate by a scale factor of 2, you're just going to multiply the coordinates by 2. Alright, you just can't get any simpler than that. So, so for example, the point T, the original point T is -1, -2. Yeah. And the original point S is the point 3, -1. So, to do a dilation from the origin, you just multiply by the scale factor. So that means that the point T prime, multiplying everything by 2, is going to be -2, -4. Alright, and S prime is going to be 6, -2. Easy peasy. So -2, -4 would be right here. So that should be my T prime. And 6, -2 would be right here. So that would be my S prime. Alright, that is the simplest and fastest way to do this. Okay, there you go. Now, if you really wanted to do this by the arrow method, you could. And the way you would do that is say to yourself, okay, here's the center of dilation. And here's the path to point T. The path to point T would be left 1 and down 2. Okay, so if I'm going to do a dilation, you can think of it as either doubling this path, which would mean instead of going left 1 and down 2, I would go left 2 and down 4. Okay, or some of my students like to think of it as just do that path again. So if you went left 1 and down 2, since we're doubling it, you could go left 1 and down 2 again, and that's a way of doubling it. Either way, you land at this point, and that would tell you your T prime. Okay, so that's how you would do it graphically. And you would just repeat that for point S. From the center, which is the origin, to get to S, you would have to go right 3, down 1. Alright, so you could, since we're doubling, you could just go right 3, down 1 again. Or you could have said to yourself, instead of doing it twice, you could have said, alright, if originally it's right 3 and down 1, then after the dilation, it's going to be double that. So it should be right 6 and down 2. Alright, two ways to think about it. Either way, you get the same point. Okay. Alright, so you could have done it algebraically or graphically, either way, this would be your answer. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.